That's true, all right. Yeah, I'm working at the Bavarian Center for Automotive Safety in Ingolstadt, of Technische Hochschule Ingolstadt. And we're doing a lot of research in automated driving. So Katrina already gave you a brief overview of some of the works we do. But we also do not just fancy stuff in level 4, level 5 automation that is years ahead from now, but also often look at problems that already exist. But this does not necessarily mean that the research we do is less fancy because of that. So what I would argue is the biggest problem we currently face with automated driving technology that is already implemented. It is over-reliance or over-trust. So we had many of these incidents already. We also had people that were killed because of accidents, like the famous Tesla autopilot accidents in 2016, or last year we had this deadly accident with the Uber self-driving taxi. So the problem here was, beside other things of course, but what was critical is that the drivers failed to monitor the automated driving system properly. In the special moment when they needed to react, they couldn't do it. And this happens in many other accidents too, not only deadly accidents. So we had also minor accidents like a Tesla Model S cranking into a van while on autopilot, where the driver afterwards stated, "Yes, I could have reacted sooner, but when the car slows down correctly 1,000 times, you trust it to do it the next time too." There were also some studies. So Volvo did a nice study last year on a real test track where they told participants about the limitations of the system and even encouraged them to keep the eyes on the road and their hands on the wheel. But still, in nearly 30% of all the provoked accident scenarios, the drivers crashed. So the question is, how can we mitigate this monitoring behavior and destroy these overtrust issues? So we know that monitoring is very challenging, even for highly motivated human beings that they want to monitor all the time, not speaking of people that try to engage in secondary tasks on handheld devices or something like that. And that's called the irony of automation. So to counter this, there is a very mighty tool that has been invented. It's called the reliability or uncertainty display. So the idea behind this, if we present the current reliability of the system to the user, then he might find out on his own how likely an intervention will be in the next seconds or minutes. So these reliability displays are investigated in many studies these days, and they have shown benefits in both level 2 driving and also level 3 or level 4 driving. But the question is, what is about the secondary tasks we want to perform? We already heard that this is one of the essential things why automated driving should be implemented. And we know that currently it's forbidden to use handheld devices, even with these level 2 systems, but we argue that if we want to make automated driving success, we must come to the point where we'll be allowed in the future then again, because otherwise it would make no sense for us. So, and when we think of what secondary tasks mean, it mostly means that we use our eyes for something different than monitoring the road. So the classical reliability display would then act just as a proxy. It still demands my visual attention from time to time to see if everything is all right. So, but Intelligent UI says we should use the full range of human interaction capabilities and build multimodal interfaces. So, and last year I met Dmitrijs and Marianna from the University of Sussex, and they are doing a lot of studies with sense and olfactory. So why should we use sense in vehicles? First, the sense of smell is widely unused. We have no scent interfaces in the car already. We have haptic interfaces, we have auditory interfaces, we have visual interfaces. And it also provides some unique advantages. So first is the evolutionary oldest sense we have as living creatures. And it's very efficient in activating the central nervous system. So the perception time of this sense of our nose is a bit longer than for the other senses, but in contrast, the sense don't have to traverse through the thalamus, they directly reach the primary cortex instantly. And using such olfactory notifications have already been proven to be a valid way of gaining user attention. They can act as arousing, for example, if drivers are drowsy, or they can also be calming if drivers are stressed. So when we integrate all these together, we may ask ourselves, the sense of smell, but also the concept of trust in automation have a strong emotional component. So why don't we combine them together in an olfactory reliability display? And this is what we did in this study, what we evaluated. We said we want to build an uncertainty display that communicates performance with sense. So in our study, we used it as a binary display. Performance is either good or bad. So usually it's done on multiple levels, but we want to keep it as simple as possible. So in our study, users had to control and monitor the vehicle while simultaneously doing a side activity on their smartphone. So in our test, only braking was necessary. We wanted to keep the experiment simple, as I said, so there was no need to engage in the steering wheel, something like that. And we attached the olfactory device, you can see it on the right, to our car, and communicated changes in reliability with 2 scents. So we used lemon, from a change from high reliability to low reliability, meaning that in this case, the driver must more often monitor the vehicle because errors are likely. And we used lavender as an indicator that the reliability goes up again. So telling the driver he could calm down a bit, there is no need to monitor that frequently than before. So we used then the reliability display as a within subject independent variable in our study. We had 3 conditions. We had a baseline drive where we presented no reliability information at all. We had a visual reliability display with the 2 symbols you saw on the slide before. It's either high or low reliability, and we had this olfactory condition as a 3rd one that in addition to the visual stimulus also added the communication of these scents. And we wanted to answer the following research questions. Can olfactory notifications increase driving performance? Can they increase the performance in side activities? And are those olfactory notifications accepted or trusted by users? So my first guess was, would I really want olfactory things in my car? I don't know, but I'm just one guy, so we have to ask many other people what they think about that. All right, for the driving scenario, we were kept very stick to the original driving scenario presented from Bella and Hazen in their famous uncertainty display study that is quite some time, 5 years old from now. And here we had a highway scenario where our car was always on the left lane and encountered slower lead vehicles. So in the high reliability situation, the ego vehicle always slows down automatically, while in the low reliability condition, the subjects had to realize that the system fails and to brake manually in 2 out of 4 cases each time. So each drive consisted of 24 lead vehicles. Then they got to the right lane, they changed the lane to be able to accelerate again and reach the next lead vehicle. And we had 3 alternating phases of high and low reliability in each drive. So for our side activity, we used a detection response task we implemented on a smartphone with an HTML5 JavaScript application where every second is a number between 0 and 9 appeared on the screen. And always in case the number 6 appeared, participants had to press the button on the bottom. So what did we measure in our experiments? We collected the driving performance measures, so to say the braking behavior, how long did participants brake, how intense did they brake, and also the task performance, so the true and false positive rate in the detection response tasks. We also used some subjective scales. We used the trust scale from Gian Pesant's, very famous in trust research, the classical technology acceptance model, as well as the PANAS positive and negative effect scale. We also did some semi-structured interviews. We had 25 participants with a mean age of 24 years, and 10 of them were female, 15 male. So you can show the short video how this looked like. We have the big reliability display on the right and persons doing things on the smartphone. And we also used these headphones, and this had a very special reason. So this olfactory scenting device, it was very noisy. So we had to keep participants from realizing that a scent is coming just because they heard the device is working. Okay, so let's come to our results. I start with the objective measures. So when we look at driving performance, we didn't find that big differences. So there was some tendency visible only in the post hoc test that the participants with the olfactory condition braked a bit less intense. And considering the performance in the secondary tasks, we had a difference compared to the baseline and the olfactory condition, considering the false positive rate and also the true positive rate. But the thing is, they were only visible between the baseline and the olfactory condition, and the effect sizes I'm not very enthusiastic about them. But no matter what. So considering the subjective measures, but the scales we used, we can see that we found many statistical differences here. So considering trust, both the olfactory and visual reliability display was rated as much more trustworthy than the baseline drive that had no reliability information at all. But the olfactory interface differed to both the baseline and the visual reliability display in cases of distrust. So they thought the other to induce much more distrust among our participants. In the technology acceptance model, we have also for the perceived ease of use, for the perceived usefulness, only differences between olfactory and reliability to the baseline, and the big, or let's say the big advantage of the olfactory display was mostly here at the dimension attitudes towards using the system, where we had differences both to the baseline drive but also to the visual reliability display. And similar also when it comes to the intention to use the system, the olfactory condition differed or was rated more positive than the baseline drive. And finally, for the PANA scale, the olfactory system also induced much less negative effect than the other conditions. So if we think of all our results, considering our objective measures, we did not find a real clear statistical proof that driving performance was increased. We had some tendencies that subjects tended to brake smoother, meaning that they had less average intensity in their braking, but a similar duration. We also have some small effects for better performance in the side activity, mostly on the false positive rate. But when we think of the visual, of the positive aspect of the visual reliability display, this didn't differ to the baseline at all in none of the measurements we take. So to finally find out if both the visual reliability display and the olfactory one leads to better driving and performance in secondary activities, we need to do more experiments and get better insights. So no matter what, so when we asked our participants using our scales and also the semi-structured interviews, there was a high preference for reliability displays in general, which is somewhat obvious, I would say. And that olfactory notification, and that was I was wondering, because before I said, I'm not sure if I want sense in my car, but many other people obviously have no problem with having sense in their vehicles. And it seems that these olfactory notifications are able to compensate some of the negative effects of the monitoring tasks. They invoke less distrust and negative effect, which will higher attitude towards using the system. And this is a bit clear to me, because in the end it means I don't have to watch two things simultaneously all the time. I could just wait for notifications on another sense to find out if I should engage or not. So what does this all mean? So first of all, it's strange that we didn't find these differences. We used a very similar formulation of our driving task than in the original study by Bella and Hazen, but we didn't find any differences as they did. So I would say that especially trust is an abstract thing that is extremely difficult to study, especially in lab experiments where people interact with the system for the first time, but only a short amount of time. Yeah, I would say what we really would need is data from real life interactions. So I would engage car companies to evaluate their own systems, how and when they are used, in which context, in which environment, maybe combine this with driver state assessment and find out how people trust and use those systems. But on the other hand, also to utilize reliability displays. So when I talk to car companies about the things like reliability displays, they sometimes say that, no, we want to give the impression to consumers that our systems are not perfect. But on the other hand, I would argue that what would be more fair and also nice for a consumer if my own car can even predict his own failures. So I think this it would for me mean that my car is more intelligent and it would just have random errors from time to time. And finally, olfactory notifications indeed could provide a valuable extension to prevent the overtrust issues. So we have this old Tesla accident where the driver did not react to multiple warnings prior to the accident. Maybe he could have reacted to some kind of olfaction. So Because, and this is the last thing that I want to say, how do you react when you are driving in your car and one of the warning light goes up? You see the warning light, you say, oh, car is still working, let's continue to drive, we'll see later on what happens. But what do you do when you smell the scent of a broken engine? I bet that most of you immediately turn over and want to find out what's the reason for that. So, okay, thank you.
Hi, my name is Kong Chen. I work for Argo AI, which is a self-driving car company, by the way. I don't know how often do the participants receive the olfactory notification, and when they use it for a long time, did any of them become less sensitive to the smell?
So in our experience, they had in each condition each scent 3 times, because we had 3 phases of high and low reliability, and these were alternating. So I'm not the expert in olfactory, so that I can't tell you how many times you should smell a certain scent before you don't react to it anymore. But still we have this effect of this strong emotional component. This means that when you experience a scent, you quickly feel like in these situations that you have associated with this scent. And this can happen even years after you had these first experiments, and it's much stronger than with the other senses.
Thank you. Yeah, it's very, very interesting to kind of include different senses. I kind of want to extend what the previous person asked. So it's not just the frequency of senses, but it's like the intensity of the senses. But it's also what other senses are present in the vehicle. If you have takeout in the vehicle with you, and it's a kebab or whatever this may be, and it covers the smell of lemon or lavender. And also, as people age, they tend to change their perception of a smell. And obviously, if we are to develop a system like this, I assume you also want it to be usable by people who have limited, or so that people of older generations are limited olfactory abilities.
Yeah, you're completely right. So I don't want to make the impression that I would argue for using sense all the time for communicating information in the car. So all those things change, and I'm completely with you. What I more want to say is that when all, and this is the, basically when to use sense, this could be the question, what would be intelligent about this system? In the way I presented it, nothing, but it would be interesting to find out that you use driver state assessments, which sense we should use for a particular situation to communicate information. But what I want to transport with the study and with the scent is that in case where anything else has already failed, the driver did not react to warnings, visual warnings, auditory warnings, why not just giving him the impression that your motor is broken down and grab his attention with a very bad scent? And obviously in our experiment we couldn't select any scent that we wanted to use, because I would have opted for this broken engine oil scent, but we just had to choose between 6 different scents, and we used lavender and lemon in the end. So that's right.
Maybe we have one over there.
Thank you. I just want to continue on that line of thought for a moment, because you're really kind of implying that there's a clear semantic correlation between the scent that's in the car, right, and the user's understanding. And the one you described is essentially a cultural or learned response. If I go to someone who's only driven an EV, for example, and has no knowledge of an internal combustion engine, they don't have that same association. And so I guess the question is, you know, are these semantic meanings that we connote with these different odors, are they innate or are they learned from experience? And if so, how can we rely on them for semantic meaning?
Very good. Actually, I would like, I like lemon. Yes.
Yeah, they're learned by experience. So, and as you say, when we had just electric cars, people will not know how a broken engine smells, but maybe we know how broken batteries smell or something like. And still, so with all these interfaces, it's not like that I would expect that at some point we could just release the smell and rely on the driver to react in the right way of course, you would have to describe these Emanuels, maybe do some kind of test and training, and make him clear that this is one way of how the car can interact with him. And we were talking about personalization too, and many people in our study said, oh, it was somewhat nice, but I tell you, I hate lavender. So even the way that maybe a user could choose which scent he would need for a specific purpose could be useful, I guess. So.
I think maybe one last question. Michael, you want to ask a question? Or? Okay. Okay, great. So, so thank you for attending Automated Driving Session, and let's thank all the speakers once again.